Starting on page 829 of our textbook, we will be looking into section 12.5, the volume of pyramids and cones. If we know the last section, the volume of prisms and cylinders, getting to know the volume of pyramids and cones will be a little bit more simple than before. So first I have a picture of a cube and a pyramid inside of that cube. I should be able to deduce that if I were to fill up the pyramid with some sort of liquid, that it wouldn't fill up the entire cube here, or the prism. So I should know that it's not going to be the full base times height, but it's going to be a little bit less than that. So first and foremost, it's important that you guys know the volume of a prism and the volume of a cylinder and how they are similar and how you can actually change the volume of a cylinder to fit the kind of base that you have, a circle, whereas the prism, I can't put a specific formula down for that because the shape of the base might change. So either way, it's the area of the base times the height of the prism. Alright, so the volume of a pyramid, it is equal to exactly 1/3 times the area of the base multiplied by the height. So if I had a cube and then I had these pyramids, I could actually fill up the pyramid 3 times with liquid and pour that liquid into this cube each time, and it would actually perfectly fill up the cube. And very similarly, the volume of a cone. So there's an example of a pyramid to the left and a cone. It looks like an ice cream cone. You guys should about know what that looks like with a radius. Volume of a cone is still 1/3 area of the base times the height. However, with cones and pyramids, I know that they're going to have a similar relationship that the prisms and cylinders do. So I can actually get a little bit more specific with the cone. So the area of the base, it's still a circle. So pi r squared times the h. So the prism and the pyramids, they stay a general formula with the area of the base because I don't know my base shape. Whereas a cylinder and a cone, we can get more specific and put in the pi r squared. So I'm going to walk through example 1 at the bottom of page 829. So in example 1, I have both a pyramid and a cone. So first I want to go ahead and write down my formulas. I always think that it is good to do this. Alright, and I'm going to get specific with the cone here. 1/3 pi r squared times the height. And I do want you guys to remember that there's a difference between height and slant height, so you got to know which one you have. We need the actual height, so the straight up and down with the right angle. Alright, I am given the actual height. I'm not given the slant height, what would be the slant height on the sides. So I can plug that in, but first I need to find the area of my base. So B, or the area of my base, it is a triangle. So it is a triangle. So that means I'm going to need 1/2 little base and little height, and these two sides, 4 and 6, they do meet at a right angle, so that means one is a base, one is a height, and the area of that is going to be 2 times 6, so 12. Alright, so I'll be able to plug that into my formula for B. So the area of my base is 12 meters squared. And then my height of my pyramid is 9 meters. So that's going to end up giving me 36 meters cubed for my volume. And then for part B, this is, if you guys remember me briefly mentioning it, if one of our solids is kind of tilted or slanted, it's called oblique. However, here, it being oblique does give me the actual height, so that's nice. I don't have to use the Pythagorean theorem to find a height if they give me a slight height. So let's just plug in our information. 1/3 pi. I'm actually going to take pi out of the parentheses. Pi, and put the r in parentheses, 2.2 centimeters squared, times my height, which is 4.5. So I can guarantee somebody's going to end up typing this into a calculator wrong. You need to keep in mind this fraction right here. It may follow the order of operations, and you might get some sort of funky divisioning and powers thing happening with the squared and the fraction. So just type in your parentheses and make sure that it's nice and clean and organized, and everything will turn out all right. So this is actually going to come out to 7.26 pi, and if I multiply that out fully, that is about, rounded, 22.81 centimeters cubed. The most important part is that you're just plugging in the information that they give you, and if you don't have what you need to think about ways to find the information that you need. Okay, so I'm now going to move on to example 2. Example 2 on page 830, they do not give you all of your pieces, however, they do give you the volume, which means that you're looking for something else. It reads, originally the pyramid had a height of 144 meters and the volume of 2,226,450 cubic meters. Find the side length of the square base. So I have a square pyramid, which that is nice, as the base will just be side squared. Alright, so I need to find the length of the base. Length of the base, alright, which I'm just going to mark that as L, and then I've got my height here. So in my formula, volume equals 1/3 area of the base times the height. I don't know the area of the base. However, I do know 2,226,450 meters cubed goes on the left side. Substituting that in for volume, and I've got a 1/3 times the area of my base times my height. So that means I can go ahead and divide each side by 144 to move that number. And then I can so that'll get rid of that. And I can multiply each side by 3 to get rid of the 1/3. Alright, so my base, area of my base is equal to 3 times 2,226,450 over 144. And that is going to come out to 46,384. Alright, that's the area of my base. However, I know the area of my base. It's L times L, because it's a square. So it's L squared. So that is L squared. Alright, so I should be good until here. Then I need to take the square root of both sides in order to solve for the length. So the length equal to the square root of 46,384, and that approximately rounds to 215 meters. Alright, so that is example 2. Another example, what if they don't give me all the pieces and I have to use my previous knowledge, Pythagorean theorem, or my trig functions? Let's go ahead and work out example 3. So, first and foremost, I want to find my radius, alright? According to the angle that I am given, I have the opposite side and the adjacent side, so I'll be using tangent. Tangent of 65 degrees is equal to the opposite over the adjacent. In order to solve for the radius, I need to multiply each side by r to get the radius out of the denominator. And then I divide each side by tangent of 65 to isolate my variable. Tangent of 65 degrees. Alright, so cleaning up this mess, r is equal to 16 over tangent of 65. which comes out to about 7.46. Alright, and these are in feet. This problem has it in feet. So that means I now have my radius, and I can use my formula. 1/3 base times height, or it's a cone. 1/3 pi r squared, well, I now know my radius, times the height, which is 16 feet. And if I type this incorrectly, making sure that I don't mess up with my fraction and my exponents, my volume should come out to about 932.45 feet cubed. Alright, I'm going to work through one last example, throwing everything at you that I possibly could. Okay, in this example, I am given a couple pieces of information, but not what I need from the start. So, let's break it apart. This is a pyramid. It is in fact a pentagonal pyramid. Alright, it is a pentagonal pyramid. So I will be using 1/3 area of the base times the height. And I'm actually not given really explicitly the pieces that I need for the area of my base, nor the real height of my pyramid here. I'm given this slant height. So let's go ahead and start out with the area of the base. So here I have a pentagon, and I have that each side is 6 feet. So this means I'll be using 1/2 the apothem times the perimeter. Okay, so I do know that since it is a regular, it does have it marked, it's regular, that my perimeter is going to equal 5 times. My perimeter should come out to 30. Alright, so that's at least one piece for the area of my base. Alright, so I'm going to plug that in. 30. Now I need to find the apothem or apothem. Well, since each side is 6, if I divide that in half, I'm going to be using this right triangle. It is 3. I do need to go ahead and divide up the degrees of the central. So it's going to be 360 divided into 5. So 360 divided by 5 is going to give me 72 degrees for each one of these triangles, which means that each one of these triangles is going to be 36 degrees. So in order to find, I'm going to draw this a little bit bigger for you guys, 36 degrees, and this is 3. In order to find my apothem, I need to use what trig function? So I have the side opposite, and then I need to find adjacent. So I will be using tangent of 36 is equal to 3 over x, and just like in the last problem, I'm going to multiply each side by x and divide each side by tangent. So x equals 3 over tangent of 36. So my apothem, or x here, my apothem, is going to round to about 4.13 feet. Alright, so now I can go ahead and plug that back in, 4.13. And find the area of my base. This is the area of my base. All of that for the area of my base. So 0.5 times 4.13 times 30. Alright, and that should come out nice and evenly to 61.95 feet squared. Okay, we're a little bit of the way there. Majority, I would say majority. 61.95 feet squared. And now I need to find my height. So right now, if I have my slant height, let's switch slides on there. I now need to use a different kind of triangle than I used before. So if I pull out this triangle, I'm not going to be using 6 feet. And I'm not going to be using my apothem because my apothem would draw right there. So this triangle that I drew, I need to find my hypotenuse. Now that I have found my apothem, I can use the Pythagorean theorem. 3 squared plus 4.13 squared should equal my c squared. So I'm going to go ahead and find what c would equal, plus 4.13 squared. And this hypotenuse here would come out to 5.1. Alright, so that means the bottom of this triangle is 5.1 feet. And this is 10 feet. Now I need to use the Pythagorean theorem again. Do you see how we're dealing with different triangles? You could have also, for the record, when I'm finding the hypotenuse for this, we could have actually ended up using the sine of 36 equals 3 over, I'll just put h for hypotenuse. We could have used that as well, and it would have come out to about the same answer. It may be 1/100th off or something like that. So now I need to find the actual height, the height of my triangle here, the height of my pyramid. So h squared plus 5.1 squared equals 10 squared, which we know is 100. So rearranging this, I'm going to get 100 minus 5.1 squared, and my height of my pyramid is going to come out to 8.60 feet. Alright, now I have all of my pieces. This is an obnoxious problem, and I can type in all of these, making sure that it's nice and neat. And when I do that, 1/3 times 61.95 times 8.6 should come out to 177.59 feet cubed. This is as bad as it can get. However, I don't think what I will assign you for homework will necessarily measure up to this, but you guys know how to deal with Pythagorean theorem, and you know how to deal with trig functions, and you should know the formula for the area of any regular polygon, as well as 360 degrees with central angles, and being able to piece it all together and multiply properly. You guys can do this.